Students, in this session, we are going to discuss about Kerberos and symmetric key agreement as a part of key management. So we are still in the symmetric key distribution itself. Then we will be discussing about asymmetric key distribution, that is public key distribution. See, this is the last session in the symmetric key distribution. As a part of that, we are going to discuss about the authentication protocol, which we call that as a Kerberos. And for the purpose of the session key creation, we need symmetric key agreement over here. So let us move with the outline first. As we are discussing about the authentication protocol, will be knowing about its structure and the servers which we are going to utilize in Kerberos. Then we will be having the symmetric agreement with the use of exchange algorithm. So let us see what is Kerberos first. See, Kerberos is the authentication protocol which is dealing with the KDC. See, as we know, KD is a key distribution center, where this center will be having a number of requests from a number of users, where all the users will be called as authenticated once they have got the session key or the secret key between the user and KDC, as we discussed in the previous session. So user and KDC will be having a common secret key dealing for the purpose to communicate with other users. So all the users will be in communication with KDC. So if KDC as one of the center process, then Alice want to communicate with Bob. So Alice will be sending a request to KDC. Thus KDC will be giving an access. Along with the access, it will be giving a common secret key access to the Bob, so that these two people will be communicating with each other, as we know this in part of the KDC. Now, Kerberos will be sending our data in the form of client server programs. See, when we have KDC as one of the part, so this KDC will be acting as the authentication protocol here. All the users will be in communication with this authentication protocol server to communicate with the remaining users in the same network. So when we are saying in the same network, all the users will be called as the clients and all the servers will be called as the real servers, right? So to declare here, Kerberos is not a protocol which is dealing with person to person. It is from client to server. So this was designated by MIT to prove this authentication as a one of the main entity or the service provided by this protocol. Now here we have three types of servers. First one is authentication server, second is TGS, ticket granting server, and the last one is the real server. Real server is the server where the exact services will be provided to the user, whereas ticket granting server is a server where the communication will be having with n number of sessions between two users. So two users must get a communication procedure. So that procedure is called as a ticket. So this ticket will be granted by TGS server. Now, at last, we'll be having the authentication server. So this authentication server itself, the KDC. We call the KDC in the Kerberos as authentication server. Now, this KDC is responsible to grant a user as an identity with a password. Now, this server is also responsible to create a session key between the user and the upcoming server, that is TGS. So, a user and TGS communication will be possible only by the ticket generated by the authentication server. So, the mediator between user and TGS is a authentication server. So, thus this server will be providing us a session key to communicate with TGS. So with that session key, a TGS will be activated, and TGS is responsible to communicate with the other end, that is Alice to Bob. Here Bob will be any server, Alice will be any client, right? So Bob as a server will be providing all the services and Alice will be utilizing those services as a client. This is the main procedure of Kerberos protocol. Let us see its diagram in detail. See, the diagram is having 3 servers as we discussed just now. The first one is the authentication server here. Next is the TGS and last one is a real server. So the main server which is providing services to the user is the real server. Here we call client as Alice and the server as Bob. So let us see the procedure. First, Alice will be requesting to communicate with Bob in terms of KDC. So KDC as a key distribution center will be holding 2 servers, that is the authentication server and ticket granting server. So first, authentication server will take the request and analyze is this user is authenticated or not with few validations and verification. Then authentication server will be providing a TGS ticket to connect with the TGS server. So this is the second step. The third step is with the ticket sent by the authentication server to communicate with TGS, it will start communicating with the ticket granting server. Now, ticket granting server will generate a session key to communicate with Bob and sends to Alice. Now, Alice is having a session key to communicate with Bob directly. So, it will be giving a direct access to the server. Now, server will be accepting the request of user Alice and they will start their communication in a proper way. So this whole process is called as a granting access, right? So the Kerberos protocol, the successful final step is called as a granting access, right? So this is all about the Kerberos protocol. Next is about symmetric key agreement. Symmetric key agreement. Here, symmetric key agreement is very important in case where there is no KDC concept. So when we don't have KDC, then we will be moving with the symmetric key agreement to generate with the session key, right? So how to generate this session key is the agreement procedure, whatever we are going to say in this session. Now, Alice and Bob both want to communicate with each other. Thus, they need their secure channel to be locked with the session key. So for the generation of this session key, we need to go with this agreement procedure. Now, why we are into this procedure is when there is no utilization of KDC. So when we'll get the situation of ignoring KDC means when KDCs are getting n number of user requests, so KDC will be in unmanageable state where all the users are keep on attacking with the request to provide the session keys, right? So at that moment, certificate authorities or the channel which is having secure protocols will be taking a decision to provide with the session key at that moment itself. So for this purpose, we go with the symmetric key agreement and the algorithm which we are going to utilize is the Diffie-Hellman key agreement. See, Diffie-Hellman key agreement can be possible in symmetric type to generate session key as same as the asymmetric type. So already we have seen Diffie-Hellman key agreement in terms of asymmetric, where we have gone with the agreement to exchange public keys first, and then after exchanging the public keys, we have to take their own private keys to generate the session key. So once the session key is generated by both sender and receiver, the generated keys will be same at sender and receiver. So this is what we have seen in Diffie-Hellman key exchange algorithm. So that is the same procedure we are going to follow up here, but here symmetric key, when we say symmetric key, the procedure is only one key between the sender and receiver, I mean the same key, right? So for this purpose, both the parties, both the users must create this symmetric key without utilizing KDC. Now for this purpose, we have to choose two numbers, that is P and G. P is any large number. It can be up to 300 digits. Okay. Then G is any global value. So it may be any number which is going to be calculated by us, right? Now choose a large number first, an integer. That integer will be called as any number selected by the sender. Similarly, at receiver end also, I mean, both sender and receiver must choose their own number x and y. So x is chosen at Ellie's side and y is chosen at Bob's side. Now we are going to apply one formula that the chosen number g to the power of your value x mod p. So p is any prime number and g is any global value, right? So after taking this step, you will be getting R1 value, right? Now, similarly at Bob's side, we perform the same thing, g to the power of y mod p. Now, p and g are two global values which should be available to both sender and receiver. Now, after having R1 and R2, both Alice and Bob must exchange their R values. So, Alice must have R2 with him and Bob must have R1 with him. So, the exchange must be taken. See, after this, the only step which we are going to perform is Alice side, as we received R2 to the power of its own private number, that is x mod p. Similarly, at Bob's side, just now he has received R1 to the power of y, his own key, to the mod p. So this value and this value will be providing same key at both Alice and Bob. So this is nothing but R1, when we say R1 to the power of x mod p, so this is taking to the power of y. So this is nothing but g to the power of xy mod p at R1 side, I mean Alice side. So that is what the k we get. Similarly, at R2 side, I mean Bob's side, we will be having g to the power of y mod p to the power of x totally. So again, we get g to the power of xy mod p. See, R1 and R2 both are giving same value k. That is g to the power of xy mod p. So that is what this algorithm is providing, same value. This is the algorithm which we have. See, once the Alice and Bob exchange this R1 R2. See, Alice is performing g to the power of x mod p. Bob is performing g to the power of y mod p. Now, p and g are public to each other. I mean, the global values. X is chosen by Alice and y is chosen by Bob. Now, after calculating R1, Alice will send R1 to Bob. After calculating R2, Bob will send R2 to Alice. Now, after this step, k will be generated. So, this k is nothing but g to the power of xy mod p. This is a common key between both Alice and Bob. Even though they are generating separately, the value of your secret key will be same at both ends. So this is the best example which we are going to evaluate within just 2 minutes. See here, G and P are two values. Now Alice chooses X and Bob chooses Y. Just we perform R1 and R2. That is G to the power of X mod P at R1. This is G to the power of Y mod P at R2. So we'll exchange these two. 21 will be sent to Bob and 4 will be sent to Alice. After this, we perform the same number, that is R1 to the power of X mod 23. So you will be getting the value 18. Similarly, this side R2 to the power of Y mod 23. So we will be getting the value 18. So even though Bob and Alice generating separately with their unique numbers X and Y also, you will be getting the value that is same key, that is 18 to both sides, right? So this is a Diffie-Hellman key agreement algorithm. If you have any doubts about this, just feel free to contact anytime in the college or through comments. Thank you.